Hello, this is ECE532, team number 9. We are going to present hardware approach of forward propagation in neural network on FPGA. First, just to give a brief project overview, we build a two-layer neural network with forward propagation implemented on hardware and backward propagation on microblades. This neural network will be able to recognize handwritten digits using the MNIST database to train it.
So here's the block diagram. There's two PCs and two FPGAs. The first PC will send the image file and the label file to the first FPGA, and then the first FPGA will receive the image and save it to the DDR, then transfer it to the neural net through the DMA. Then the output will be transferred to the second FPGA through the Ethernet. The second FPGA will receive the data, compares to the test labels, and then send the result to the second PC. The second PC will run the visualization program using Python.
In terms of our results, we were able to achieve a 784 by 16 by 10 neural net on the Nexus video board with pre-trained weights and biases. This allowed us to get 8 microseconds for processing one image with a 100 megahertz input clock frequency. In doing so, we were able to send the test images to the neural network through a DMA communication from the DDR. And then we were also able to send the test labels and the output results to the second FPGA in real time through TCP connection. And then finally, we were able to visualize the overall accuracy and digit accuracy in real time on the second PC with PySerial. In the bottom right, we could see the digit accuracy and the overall accuracy. And in the top right, we could see the full 10,000 image accuracy of roughly 92%. Here on the client side of our system, we are on the first PC that is connected to the client FPGA. And we could see visually that it is processing images at a time on the neural network. We are currently configuring it to process 10,000 images. These images could be visualized on here on the left on this program, as you can see 7 to 1 and 0, and the corresponding labels right here, 7 to 1 and 0. These images are sent through UART through this Terraterm program we are using, and we are able to send these files with these images as one full file over to the first FPGA, and that is saved on the DDR. And once that's saved on the DDR and the labels are sent to the second FPGA, we are able to then process it through the neural network. And we do that through DMA transaction. And then once that data is processed, we store the output to the DDR, and then the Ethernet then sends that data to the second FPGA, and that will be our server FPGA. And now we will talk about the server side of our system. Here on the server side, which is what we're seeing is the second PC, which is hooked up to the server FPGA or the second FPGA. We can see on the left the output of our Python program as it is receiving data from the first FPGA and verifying the accuracy for us of our model. And we can see in the figure on the right, the various plots. The plot in the top left visualizes our overall accuracy, and then the rest of the plots visualize each digit accuracy. This is conducted as we are comparing the labels to the outputs that are being sent from the first FPGA, and thus we are able to then visualize the full accuracy of our system and model it and compare it to the software model of our neural net.